Okay, here's some notes and some examples on what we call the rational root theorem. And this is kind of generalized notation here, so this may be a little bit hard to follow, but when you see some examples, I think it'll be a little clearer. But if we have some polynomial and it's in this form, some number times x to the nth power, and that's how the degree, plus a sub n times x to the n minus 1, plus, and then dot, 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 means we've got some other terms, and then a sub 2 times x squared, plus a sub 1 times x plus c. So it's in this form, and here's an example just so you can see. If this is my polynomial of x, this would be my a sub n, my leading coefficient, and this would be my x to the n minus 1, etc., and then x squared, x to the first, and no x's. So that's the constant term, like up here. Let me see here. So there's the constant term, and there's my a sub n times x to the n. In this case, n is the fourth power. That's the highest power. And in this theorem, we're mostly just interested in the leading coefficient and the constant term. Those are the numbers we're really interested in, not the stuff in the middle. Okay? And as long as it has integer coefficients, and the coefficients are the numbers in front of the variable, so 2 is an integer, 2 is an integer, negative 3 is an integer, and 4 is an integer. So these are all integer coefficients. And this is actually considered a coefficient of x to the 0. So these are all integer coefficients. So if we have all these things happening, then every rational root, or 0, sometimes we call them 0, sometimes we call them roots, or even x-intercepts, of p of x is a number of the form, and it's going to be a factor of the constant term over a factor of the leading coefficient. Okay? Any rational root, so we're going to be finding rational roots, so we're going to use this theorem to help us kind of narrow them down. Okay, so here's an example. So again, you could look at that. Like I said, sometimes these are a little bit tricky when you write them in these general forms, but when you see an example, you'll see how easy it is. So it says list all possible, an example, list all possible rational zeros or roots of the following functions. And here's a, f of x equals this. So we look at just the leading coefficient and the constant term. Here's the constant term, and here's the leading coefficient. And it's just all the factors of the constant term. So what are the factors of 6? Well, we've got plus or minus 1, plus or minus 2, plus or minus 3. Does 4 go into 6? No, the last one is plus or minus 6. So those are all the possible factors of the constant term. Now, what are the possible factors of the leading coefficient? So I'll write a fraction bar here, or a little bar here, because it's going to be over that, of that form. And what are the possible factors of 2? Well, plus or minus 1 and plus or minus 2. Those are the only two numbers that go into 2. So it's going to be of the form these factors over these factors. So I have to take all the possibilities. So first of all, I'll do. And we're going to have plus or minuses over plus or minuses. So they just end up being 1 plus or minus. So we'll have plus or minus 1 plus or minus 2 plus or minus 3 and plus or minus 6, and those are going to be over 1. So I got plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1, and then I've got to take all these and put them over 2. And we could put commas in here just to separate them because it's a list. And we have plus or minus. So again, the same thing, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And these would be going over, in this case, plus or minus 2. And all these plus or minuses mean it can be plus or minus. It will end up being a positive or negative. We have all these just different possible signs. So those are all your possibilities. So we got 1, 2, 3, 4, 5, 6, 7, 8, unless we've got some repeats. So when you simplify these things, you may have some repeats. So let's take a look at this. So this is going to end up being When I simplify this, it's just going to be plus or minus 1, right? This will be plus or minus 2, plus or minus 3, plus or minus 6, and this is going to be plus or minus 1/2, plus or minus 2 over 2 is 1, plus or minus 3 over 2, and plus or minus, well, 6 over 2 is 3. And notice we've got some repetitions, because here's 3 and here's 3, so I don't need that. And here's 1 here and there. There's 1 there, so I don't need that. So those are repeated, so we just want the unique ones. So now my final list would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, and plus or minus 3/2. So those are all my possibilities. So I've got 1, 2, 3, 4, 5, 6 times 2, 12. So 12 possibilities, if I have rational roots. There will be one of these, at least one of them will be one of the, well, they've got to be of this form, so any rational roots will be in there. One of those 12 possibilities, any rational roots. Okay? And I'll do some more examples in the next video.